Hmm. All right. Any questions about? I know there's got to be questions about MyLab because
yeah, I wasn't able to enter to the book or even the assignments on the person account.
okay. Hold on a second. Okay. So I'm setting up my script, my uh internet right now so I can do a share screen with that. Okay. This is what my homepage looks like for this class. Your homepage has fewer items over here. Well, let me click that up. So this is what your home screen should look like. And these are all the menu items you should have over here. Does everybody have the MyLab? The MyLab menu item over here? Because that is extremely important.
Yes,
Okay.
yes, I think I have.
Because I've had at least one person, well, I have one person so far who does not have this. And so that's an IT problem. So if you go into modules, you have the Red Shelf Brightware module. And how come there's nothing there? There's supposed to be something there. Oh,
No.
because I'm not a student. That's why I don't have anything there.
No, I actually tried to click it, but it doesn't show anything. Just like a circle, try to charge in something, but no.
Yeah, I click it and it shows every textbook I have that I'm using online. And so I have 6 textbooks that are exactly the same and 2 more textbooks that are the same. I have 6 classes that use the same textbook. All right. 2 of these 6 classes they're just different versions of the exact same class. So they meet at the same time. It's just 2 of them have in classroom and a remote. So I had a Monday, Wednesday, I have an 8 o'clock class that is in the classroom and remote. And so that's why I have 2 different textbooks for that class. My purely remote classes, which I have 2 of, there's just one of these for each of those classes. Now, these are for all 6 different versions of those classes. Pre-calculus and the college algebra 1414 all come from the same textbook. These 2 are from a face-to-face remote class that it's called dual modality because I have 2 ways of that this class is being administered. And so it's also college algebra, but it's a 1314. So they use a different version of this book. Okay, so that's why it looks different than this one does. But when you pull this up, only one of these shows up, and that's the one for you, for this class. Okay, so you click on it. For those of you it shows up for, you click on it, it has the remote code. And so you click on that code. This code doesn't work because I'm a teacher and I don't have a code. So they fill it in with a code, but it doesn't work. Okay. So you copy that code and then you go to MyLab and you enter into MyLab here and you go through the process of setting up an account if you do not have one. And then it asks for, and then well, it'll start out by asking, does it start out asking for the code, for the access code? I can't remember. I used to know.
Yeah, actually, there's something like they'll tell you about a code, but the one that you
So
send on
you want the access code. If you don't have the access code, down below it says something about if you're waiting on financial aid,
yeah, the free course.
there's a temporary access. Well, you click that down there and it gives you 2 weeks free. So while we're waiting for Red Shelf to get its crap together, so you can get that access code.
Okay, I was pretty confused because the other day just
Yeah.
a lot of math.
Yeah, the directions I gave you is for when Red Shelf works.
Sure.
If Red Shelf doesn't work, then you go for the temporary access.
Sure.
And then you create your account if you don't have one already.
Sir, can you hear me?
Yeah.
Did you count me or not?
What do you mean? Did I count you?
Like, have you taken roll yet?
You type your name into the chat. That's
Okay.
putting roll. That's the roll. Yeah.
All right, I got it.
Okay. What else? So that's how you get into it.
So we just use the temporary access?
Yes. If
Okay, thank you.
Red Shelf is not working for you, so when you go in through the modules and you click the Red Shelf, and it doesn't work for you, then you use the temporary access. And I need everybody to do that today at some point, because I need to give my department head who's got access and who doesn't. Or I need to tell them how many have access and how many doesn't. I don't need to know specific names, but I will know specific names. But because I need to tell them who doesn't have access through Red Shelf and how many don't have access through Red Shelf.
It's asking for an access code.
Then that's when you go down and look where it says waiting for financial aid.
Okay, thank you.
Okay. Yeah. If you sent me emails through Canvas, I had this yesterday after a certain point, or this morning. I haven't had a chance to look at them because I've been too busy having class. I'm going to post my schedule, what I'm teaching when, so you'll know when I'm in class and when I have office hours. Any other questions about this?
Yeah, after when the things get fixed, like for example, right now we have the financial aid for 14 days, but
Yeah.
we're gonna have the code after like a few days.
Well, once we get the code to you, then there's a way to, once you're in there, there's a way to pay for it. And
Oh.
that's the access code. The access code is paying for it because you've already paid for it. So I don't know that end of it, but I know there's a way. Once you're in there, you open it up again, and I don't know how you do that. I'll have to find out. Or you can go onto the Pearson page and find out how that happens. But I'll look it up, and if I can find it, I'll copy and send it as a file, and you'll find it in files over here. Once you get it open and you click into it, this is my home page for this class. Okay, it'll populate. It takes a little bit. And yeah, your grade book will look different than mine. And so for me right now, this is meaningless because only a few people have access to it and only a few people have started it. And if you haven't finished a homework assignment, it's going to show it like that. And some people have gotten into an assignment and then click back out, so it shows that as a 0 for my reckoning. But don't worry about zeros in the homework because you can always make them better. And then assignments, it shows the assignments that are due. They show the ones that the first, what is this, 5 assignments that are due. But access the homework assignments, and you use the menu over here on the left hand side and click assignments over there. The reason I prefer you do it this way is because, boom, guess what? Those are everything we're covering in this class. Actually, there should be more. Well, I'll add those later. Because I think there's a couple more sections we cover. Well, I cover anyway. Though not everybody covers as much as I do. And there's one section I like to cover, and it's from chapter 12, and it's for this course. It's the binomial theorem. I think it's an extremely important theorem to know, especially for the 1414 college algebra. And so, and what I have here is the order in which we cover everything. Please notice the section 11.2 is covered out of order of the other sections. Okay, because it deals with using matrices to solve systems of equations. And so this is the number 1 problem. And so, yeah, a matrix used to represent a system of linear equations is called an augmented matrix. Final check. Boom. Fantastic. Oh, they changed this. All right, since last semester. The attaboys, as I call them, my father-in-law. And so you create an augmented matrix of this system of equations. And so it goes through a lot of things like that. So I'll leave the page because I'm done. And so, yeah, so it shows that I've done 1 problem. And I got it correct, 1 out of 1. Some of these problems have multiple steps. And so if you have 3 steps, then if I only completed 1, then it would say 1 out of 3. Okay. Or 1 out of, or 0.3 out of 1, or 0.6 out of 1, or something like that. So I don't remember exactly how they do it, but there's 18 problems, so it's a total of 18 points. And so what I have now is 1 out of 18 points. So I could have out of 17.1 out of 18 points. And then for the grade, they convert that to a 100-point scale. Yeah. Okay. And so I go back to here. So, oh, let me go back in there. I'll go ahead and pull up the second question. And so let me see. Come on, quick, quick, quick. Hurry, hurry, hurry. Fast, fast, fast. Of course, it doesn't do that. So, oh, I don't, oh, here it is. Help me solve it. View an example. Get more help. Ask my instructor. This is where you click this. And then you type in what your issue is. If you just don't understand what it's asking, then say, I don't understand what it's asking, and then you click send. If it marked it incorrect and you know it's correct, then say it marked it incorrect and hit send. Because if all it did was mark it incorrect, I can go in there and look to see what you're talking about and give you the point back or a portion of the points back. Okay. So that's that kind of deal. And so what is they're asking here? Domain and range. Oh, the domain are these names and the range are these names, right? So Dan, Gizmo, oops, Dan, Gizmo, Ron, Maggie, Rosie, Diane. So it's that one. And so I click check answer and it goes, yay. And then I go on to the next one. So is this a function? Oh, it's not showing what I see. Damn, it's supposed to. Okay, I see why. All right, I know why. Because I pulled out of that. So let me do it this way then. Where is it? There it is. Share. Okay. So yeah. So I looked at this and it told me, and I looked at what the domain was these, and the range was these, and so that's one that showed it to me. And now I'm gonna look, is this a function? Okay.
Yes.
It is? How do you know?
I think because the persons, because the domains go directly to the, how do you say the other one? Oh, the range.
All right. For it to be a function, each element of the domain goes to exactly one element of the range. All right.
Oh, yes. All right.
Maria, Fernanda, why did you say no?
Because Ron has two names in the Y values.
Ron goes to has two different cousins. So because Ron goes to two different cousins, it's not a function. So Ron would have to only go to one name over here. It went to two names over here. So that means Gizmo and Ron are related. So they're probably cousins, and they have Rosie as a common cousin. So the figure is not a function because the element Ron in the domain corresponds to one element in the range. So that's letter B. Is not a function because Maggie has more one element. No. We're not worried about whether the names or the elements in the range have more than one. So we could have had just excluded Diane's name from this roster, and it would still have been a function because each person here only went to one name over here. But because Diana was included, Don went to 2 different names over here, so it's not a function. And so, boom, it's going to say, well done. Is there a next question here? No. Okay, so it moved on. So here's the domain. All right, this is where we got to be careful. Notice it gave us a bunch of things down here. And here in the domain, we type in the X values. So we have 2, 3, please notice I did not put spaces in. 4, 5. Oops, 5, not a 6. And I didn't type in anything. Here we go. And since they already provided the braces, I don't need to type in the braces. And hopefully it says good job. Next thing. And the range. All right. We have -5, -5, -5, and -5. All the numbers in the range are the same. So how many times do I list it 4 times? So if y'all were showing me your faces, you could shake your head and I would see you shaking your head saying no. Okay. So we only need to list it once because all they want to know is what shows up, not how many times it shows up. So I don't think it'll count it wrong if you type in more than once, but it'll fuss at you for doing that. Does this represent a function? Does each X value, so does 2 go to just one Y value? Is 3 paired with just one Y value? Is 4 paired with just one Y value? Is 5 paired with just one Y value? It doesn't matter if the Y values are the same. What matters is there two Y values that go with each of those X's. Yeah. Right, because there are no ordered pairs with the same first element and different second elements. So that's what they're talking about there. The first element is only paired with one second element. Okay. Excellente. Okay, so that's how that works. So if I close this, does that shut down the sharing? Yes, it does. Okay. So that's a brief introduction into what happens with MyLab. Please be aware that in MyLab, you don't type in spaces, because if you do, it'll tell you it's wrong. Okay, now my question for y'all is, where did we leave off? Did we do the difference quotient?
I have a question.
Yes.
So we're supposed to do the section 2.1 homework.
Get started on it. I don't think we finished 2.1 yet.
Okay, and then on the other assignments, are they going to be changed to the due dates? Because they all say the same date.
Oh, I didn't mention that. All the due dates right now are for the end of the semester. So I'm going to change those due dates as soon as I put in the exam dates.
Okay.
So I'm going to set up an approximate timeline for the class as far as setting up the due dates. Okay. Those those sections might change a little bit depending upon how quickly we get through the material or how slowly we get through the material. So I'll adjust accordingly in the due dates. So I think all of chapter 2 will be on the first exam. So the due dates of those will become the day of the exam. So don't wait till the day of the exam to start doing the homeworks. No. Because college algebra, everything builds on itself. And so you need to stay up with the stuff. Okay. That help?
Yes, thank you.
Does anybody remember what we left off on? Did we talk about the difference quotient?
Yes, we did.
Okay. And so from difference quotient, did we get into talking about the domain of a function defined by an equation?
We were doing examples with the equation of the difference quotient.
Okay, so we're still working on that.
We left off on the example f of x equals to the square root of x.
Okay. Thank you. So this slide basically.
Yeah, we completed that example.
Oh, we completed this example?
Yes, we finished
did
solving
that.
it.
Okay. And so we went on to, all right. So finding the domain of a function, we generally start with that x is a real number. Okay, the domain of function f is the same as the domain of the variable in that function. So here we have, yeah, any number, we can find the square root, we can find the square of any real number. The square of negative numbers is a positive number. The square of positive numbers is a positive number. The square of 0 is 0. So I can find these values. So it's a set of all real numbers. Now this one, we have to look to see what makes my denominator 0, because we can't divide by 0. So we look at where x squared minus 25 equals 0. And so there's two different ways of solving this. The more traditional way is looking at this as the difference of two squares. We say it's a difference of two squares because x squared is x being squared and 25 is 5 being squared. So I'm taking the difference of two perfect squares. Well, that means I'm going to get two binomials that's going to have those two square roots in them. The square root of x squared is x. The square root of 25 is 5. The square root of x is x. The square root of 25 is 5. And so those two go in there, and one of them is going to be plus, and the other one's going to be minus, and it still equals 0. So now I have a product that equals 0. If you have a product that equals 0, then one of the factors has to be 0. So x minus b is a factor. X minus 5 is a factor. X plus 5 is a factor. So x minus 5 is going to equal 0. Or x plus 5 is going to equal 0. I always put a line down between the two equations, or if I have more than two expressions, I'll put a line down between all of them, because now I'm going to solve this equation, and then I'm going to solve this equation. So adding 5 to both sides, I get x equals 5. Subtracting 5 from both sides, I get x equals a negative 5. So for my domain, that means x cannot be 5, because that'll make this equal to 0, and we don't want that. And I have x cannot be equal to negative 5, because if I put negative 5 in for x, I'll still get 25 minus 25, which is 0. Any questions? Now, the other way of solving this is to add 25 to both sides. So I get x squared equals 25, and I use the property of square root. The property of square root means if I take the square root of both sides, then I have a positive and negative square root. So that means x is going to equal a plus or minus 5. Because negative 5 squared is 25, and 5 squared is 25. So the square, so we have the plus or minus thrown in there with the square root of 25. So we get the same two x values that we have to exclude. And that's what they taught here. They didn't go through the process of finding out, of showing you how to find those numbers. They just said what those numbers are. You will find that at this level, they already assume you know how to do certain things. I'll go through and work them where they make some assumptions. Okay. So they're going to use set builder notation here to determine the set. So the solution is a set of numbers. So we're going to use set notation, which is the braces here and here, and that shows that this is a set of numbers. And so this part here is x, so we're talking about x being a real number, and this symbol here means the phrase such that. So this is a set of all real numbers x such that, and then I have a condition that has to be true, and the condition is that x cannot be 5 and x cannot be negative 5. I think they wrote it. Yeah, they did. They wrote it. They put the negative 5 first, but it doesn't matter because both of those numbers are excluded. Now, if I was to do this in interval notation, that would end up getting me 3 intervals. So we're not going to talk about that right now. Now, here we have this situation. We have a function of t, h of t, which usually is time, equals the square root of 5 minus 5t. So whenever you see something like h of t, we're usually talking about height. So after a unit of time, whatever thing we're talking about is going to be this many units high or up or away. Okay. Now, when we're dealing with square roots, what has to be true of the argument of the square root? The argument of a square root is called the radicand. So what needs to be true of the radicand of a square root. What real numbers can we not take the square root of? Oh, I don't have my chat window up. So if anybody's making a comment in chat and I didn't see it, which nobody has. Negative, right. Taking square root of negative numbers is not a real number. It's a complex number. So we're only dealing with the real numbers right now. So we can't take the square root of negative real numbers. So because it's not negative, then we talk about non-negative real numbers. Non-negative real numbers are the positive numbers. And come on, dadgummit, you're not doing what you're supposed to. Oh, I see why. Haha, my mouse was in the wrong part. Okay, so we talk about non-negative because non-negative includes 0. So we're not just talking about the positive numbers, we're talking about the number 0 as well. So we have to include 0 by saying non-negative, because 0 has no sign. So when I say non-negative, then we're talking about greater than or equal to 0. So that means that this expression in there has to be greater than or equal to 0. So if I go through the process of solving for t, so I can find out what values of what real numbers I can use for t, then I solve for it. So I'm going to subtract 5 from both sides. So that means negative 5t has to be less than or equal to negative 5. I'm going to write this down here because there's a question I want to ask. So what am I doing? What's my next step?
Divide by negative 5.
Divide by negative 5. So I'm going to divide the left-hand side and the right-hand side by a negative 5 because I want a positive t down here. But what happens when you divide by a negative? When you divide an inequality by a negative, what happens to the inequality?
The symbol switches.
The symbol switches. When you multiply or divide by a negative number, all your signs change, including the inequality sign. So it went from greater than to less than. So now t has to be less than 1 or equal to it. So this is the condition that would go in this part of set builder notation. So that means that we have the set of all t, because the variable is t now, so all times t such that t is a number that is less than or equal to 1. And there'd be an added restriction on here if we were actually dealing with something that dealt with time, because we can't go back in time. We can just have when time starts, so that'd be 0, so it'd be from 0 to 1. But yeah. But if we did go back in time, then that would work. And so, and notice that here they do talk about an interval. When I want to write it in interval notation, I look at a number line. And the only point I'm really concerned about here is 1. And so t has to be smaller than 1. And it can equal 1. So we use the bracket here to show that it equals 1. This end of the number line goes towards negative infinity. In interval notation has 2 numbers or 2 symbols in it. It's a small end and the large end. The small end is negative infinity because that's what it's heading towards. It's heading towards negative infinity. So that's the low end of the interval. The high end is where's that interval end? Well, this case, it ends at 1. Well, going to negative infinity, we never reach an infinity. Infinity is a journey, not a destination. So, but in this case, 1 is a destination, but can we reach that destination? Well, yes, we can, because it says it can equal 1. So that's why we use the bracket. If we did not have this equals portion of it, then it would have been a parentheses there instead of a bracket. Okay. Questions? All right, moving on. All right. Here we have some interesting things going on here, so I need a full page. So we have the square root of 2x plus 6. And in the denominator, we have x minus 2. In the numerator, we know what's inside that square root symbol. It has to be greater than or equal to 0. So 2x plus 6 has to be greater than or equal to 0. And my denominator cannot equal 0. So that means x minus 2 cannot equal 0. Well, the denominator is easier one to work with, so I add 2 to both sides. So that's telling me x cannot equal 2. So this is one of my conditions. My other condition is solving 2x plus 6 greater than 0. So we do the algebra here by subtracting 6 from both sides, and we get 2x greater than equal to negative 6. Did I divide by a negative number or multiply by a negative number?
No.
No, so I don't, so that doesn't affect the sign here, the inequality. Now I'm going to divide by a positive 2. Dividing by a positive does not change the signs. So this inequality stays greater than equal to, and this side remains negative. And so I have a positive x when x greater than equal to a negative 3. So these are the two conditions that have to be met for x to be in the domain. So I have the set of all x such that, and we're going to write this one first because that's what the textbook did. It doesn't matter, actually. X has to be greater than negative 3, and x cannot equal 2. Now, why do I have to put this one in? Because positive 2 is greater than negative 3. But I can't use 2 in the denominator because that'll give me 0 down there, and the function does not exist at 0. I mean at 2. So that's what they did. They did the same thing, only they didn't show you how they got those things. So the domain of f, oh, it was a capital F. Yeah, doesn't matter. Okay. So finding the domain of a function, divide by equation. First, you start with the set of all real numbers. Okay. Then if the equation has a denominator, so you exclude any numbers that give the denominator a 0. And then if the equation has a radical with an even index, then you exclude any numbers for which gives that the expression inside the radical, which is called the radicand, which is what I said before, is negative. So the radicand in this case was the 2x plus 6, and that can't be a negative number. And so that's what we did here. We excluded negative numbers. Okay. Now, does everyone know what's meant by an even index, or what an index of a radical is? All radicals have an index number. This symbol without the index number is square root. So its index is 2, which is an even number. All right. So we have, when we talk about the cube root, that index number is 3. So the index number is what root are we taking? Are we taking the square root? Square root is the most common radical we use. It's the most common root we use. And so instead of writing a 2 here all the time, the mathematicians have just decided that if there's no index number written there, we understand it to be the second root. And so the third root, and then the fourth root, and the fifth root. And so whatever root we're talking about, that means the index numbers tells us how many of these things I have to multiply to get the radicand. So I have to multiply 3 of these together to get A. And if I keep using A in here, because that's typically what we use, it takes 4 of these being multiplied together to give you A, because that's the definition of the root. Okay, square root means it takes 2 of those numbers to get the radicand. So the square root of 4 is 2, because 2 times 2 is 4. 3 is the square root of 9, because 3 times 3 is 9. So 2 is the cube root of 8, because 2 times 2 is 8. 3 is the cube root of 27, because 3 times 3 is 27. 4 is the cube root of 64, because 4 times 4 times 4 is 64. Took multiplying 3 4s together to get 64. If I multiplied 4 4s together, then that means 4 is the fourth root of 256. Yeah, that's just one of the ones I know. Okay. There's certain cube roots that are good to know. There's certain fourth roots that are good to know because they come up more often than the others. And square roots, the first 16 perfect squares are good to know. So that's squaring 1 through 16, and knowing what those numbers are is a good thing to know whenever you're having to deal with mathematics. So I always tell my students to memorize those and know them, because then you don't have to think about it. You don't have to pull up the calculator to find out what it is. So 16 squared is 256. 15 squared is 225. 11 squared is 121. 13 squared is 169, where 14 squared is 196. I used to know what 17 squared is. I think it's 383, but I'm not 100% on that one. Okay. And then the perfect cubes, 1 through 4 are most common. 1 through sometimes 5, no, 1 through 6 are the most common that they use. So that would be 1, 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. And 6 cubed is 216. And then the fourth powers, 1, 2, and 3 to the fourth power. 1 to the fourth power is 1, 2 to the fourth power is 16, 3 to the fourth power is 81. Those are the most common that are used. And to the fifth power, you're on your own. I know what 1 to the fifth power, everybody should know what 1 to the fifth power is. 2 to the fifth power happens to be, what is that? 32, I think. Yeah, it is. It's 32. 3 to the fifth power, I have to multiply 3 times 81, which is 243. So, okay. Knowing those is very helpful because they come up a lot. Those numbers come up a lot. Okay. Now, domain of a function, we express the domain of function using integral notation, set notation, or words, which is ever most convenient. A lot of times we'll just use one or the other. If it's a set of all real numbers like polynomial functions, the domain of all polynomial functions is all real numbers, then we use the phrase all real numbers. Or we could say x such that x is a real number. Or we could say all the set of all x such that x is a member of the real numbers. So we use the symbol for real numbers. Different textbooks use a different symbol for these. This is when I was at UTSA, this is the symbol most of the textbooks used for the real numbers. And then we have the rational numbers and the irrational numbers. The rational numbers is a stylized Q of some kind. Q for quotient. A quotient is a fraction, and it's a rational numbers are a fraction of two integers. Irrational numbers, pi is the most famous irrational number. So we use pi, a stylized pi for that. The natural numbers, we use a stylized n for that. And the natural numbers are the counting numbers, 1, 2, 3, 4, and all like that. And then the integer numbers is a stylized z. And the explanation that's been given to me, and I did a Google search and other searches for this, is that there's a German word for number that begins with the letter Z, and that's why we use Z for integers. So this is integers. This is natural numbers. 1, 2, 3, 4. So counting numbers not including 0. When you first learned to count, you didn't start counting with 0. You started counting with 1. Counting is, we're talking about how many things. We have 1 thing, 2 things, 3 things, 4 things. We don't have anything. So, but once we add the number 0 in, then we're talking about whole numbers. And different textbooks use different ways of notating whole numbers. One way is by using a stylized W. When I was at UTSA, we used the natural numbers plus 0. So that would be the counting numbers and 0. And then these are irrational numbers. They cannot be represented as fractions of integers. They're decimal numbers that are non-repeating and non-terminating. So the pattern of numbers doesn't repeat, and it never ends. And so these are irrational. They're insane. And these are the rational numbers because they can be written as fractions. Hence the name rational. Rational comes from the word ratio. A ratio is a fraction is a ratio. and then R is the real numbers. And different textbooks use different symbols here. They're the same, but how they denote them are going to be different. Some people use a letter I for the irrational numbers. And then for integers, I think most people use the Z. Some textbooks use an I, so they'd use a different letter here, different symbol here. I don't know, but this is what I'm used to using and seeing. Okay, done with that. Now, if X is in the domain of a function, then we say F is defined at X. That means X gives us a Y value. So we say F of X exists, or F of 3 exists, F of -7 exists, or F of X exists at X equal to 3. So there's a couple of ways of saying that. If X is not in the domain, then we say F is not defined at X. F is not defined at 3, because 3 won't work in the function. It gives us a negative radical, a negative square root, or it gives a 0 in the denominator. Okay, so we say it's not defined at that X value, or F of X does not exist at that X value, or F of 3 does not exist. Okay, another way of saying this is that the function does not exist at 3 or something like that. Okay, so here we have the volume of a cube. So find the domain. So first of all, we want to express this as a function. The formula for this is different than the function for this. The formula tells us what's the volume. So what is the volume? What's that formula on the formula chart from high school? What was that volume? Anybody remember? Everybody asleep? Come on, somebody's got to remember what this is.
Wasn't it base times width times height?
Well, that's for a rectangular solid. Length times width times height, right? Well, what is it when all three of these are the same? That's for a cube. This is when they're all different. So when all of these are the same, what is that? The volume equals what? Well, if all of these are the same and we're using the letter S for each of those dimensions, so here I have a cube.
S
and
cubed.
all of those dimensions are S. So what is it? If you said it, I missed it.
S cubed.
Yes, you get S cubed. So that's the formula. Now, how do I write this formula as a function? That means I have something being done to a variable. Well, the function name, I'm going to give the function name V. So the function name is V. What does it act on? What's my argument here for the function?
S cubed.
All right, the function acts on the side, on the length of the side, right? Which is S. And what does it do to S? It cubes it. So V of S is the function notation. And what happens to S is that we cube it. So do you understand what the difference, but these two formulas look exactly the same, don't they? Except one is a formula and the other is a function. But they represent the same thing. It's just one is represented as a function, the other is represented as a formula. Is that making sense? Yeah, different
Yes.
sides of the exact same coin. They both mean the same thing. It means when you square the length of an edge, you get the volume of that cube. Now the question is, the domain, what numbers can I use for S? In other words, what numbers can I use for the length of a side of a cube? Can I have a -1 meter for the length of that side? Why not?
Because you can't have a negative volume.
More basic than that. Can I have a negative meter? How do you cut a -1 meter length of board? How do I measure out a -1 meter? Can I do that?
I think yes, because you can take to reference one, but I'm not pretty sure about it.
All right, so here I have a length of board. How do I cut all right, let's say this is 10 meters long. How do I cut a -1 meter off of this board? Negative, when we're talking length, is direction. So when I talk about a -1 meter in football, or on a football field, when I talk about a -1 yard, I'm talking about a direction, not just a length. But the 1 meter or the 1 yard is still the same length, because length is positive. Length is always positive. It's just when I throw in a negative, I'm talking about direction. Do I care about direction when I want to cut 1 meter length of wood? Because if I'm talking negative, then I'm talking about going this direction on this foot, on this board, or I can take a meter, a positive meter from this direction. That length of board is going to be exactly the same. This length here and this length here will be exactly the same. So the negative did not matter. So the negative, I just ignore. I don't use it, because I can't actually cut a negative length of board. I can talk about a negative length, but I'm not measuring a negative length. Is that making sense? When I measure, like on football, when they measure, well, they lost 3 yards, they measure out 3 yards, but they go in the opposite direction. They still measured a positive number of yards. That is just the direction was negative.
Okay, I got it, sir.
Okay. So negative just denotes direction, where the distance is always positive. So if I'm talking about I'm traveling a -2 miles per hour, that means I'm backing up 2 miles per hour. I'm still traveling 2 miles per hour. I'm still covering a positive amount of distance. I'm just traveling in the wrong direction. Or I'm going backwards when I should be going forwards. Just turn around and go. Okay. All right. So we can't use negative numbers here. So that means S has to be a positive number, or it has to be not negative. Well, 0 is non-negative. Can I have a length on a side of a cube that is length 0?
Can you repeat the question, sir?
Can I have a length of 0 for this cube?
I don't know, because like the 0 doesn't
Well,
represent.
can you build a cube that is 0 inches on a side?
No.
No. Because we're just talking about a point in space then, which has no dimensions. Points have 0 dimensions, has no length, no width, no height. So using 0 would be meaningless here. So if I did use 0 in this formula, then it would have a volume of 0, which means it doesn't exist as a cube. So that means S has to be greater than 0. S has to be a positive number, not just non-negative. It has to be positive. So that's S greater than 0. These are things to consider, because 0 is a very special number. Now, 1 is a special number for its own reasons, and 0 is special for very significant reasons. One is you can't divide by it. The other is you can't use it in certain situations. Zeros has some very specific properties, and this is one of them. Okay. Now we're moving into using the algebras on functions, the operations on functions, adding. Oh, I don't need to worry about that. I'll just move on to another page. We're adding functions, and we're going to be subtracting functions. So G plus F plus G. This is just notation. The only thing this notation means is that we're adding these two functions together. This notation down here means we're subtracting the two functions. So it's f of g minus f of x minus f of g, g of x. Please be aware that if you're subtracting an expression, you need to put it inside parentheses. So you're subtracting the whole thing, not part of it. Was adding, the parentheses aren't so significant. All right. Now, when you're multiplying, again, you need those parentheses, because I'm multiplying two expressions together, and I need to use the appropriate multiplication techniques for that. And then with dividing, we're talking about the same thing, but the parentheses aren't so much important in this case. But I'm just using them to say that this is the expression for the f function, the expression for the g function, and then you say that g of x cannot be 0. And so, and then you just simplify this fraction if you can. So the notation here is f times g of x, which is just f of x times g of x. And then the quotient of f and g of x is the fraction f of g divided by g of x. F of x divided by g of x. I said it in reverse, didn't I? Okay, so here we have two functions, and they want us to do this with them. Okay. So letter A is adding those two together. So I have 2 over x plus 3 plus x over x minus 4. Well, I'm adding two fractions that have different denominators. So that means I want to get the denominators the same. Well, to get the denominators the same, in this case is just multiplying the two denominators. So the common denominator is x plus 3 and times x minus 4. So when I end up multiplying these together, my common denominator is going to be x plus 3 times x minus 4. And I go straight to the common fraction. And then because I'm adding, I'm going to put a plus sign here. And over here is the new denominator I'm going to get. And over here is going to be the new numerator. I mean, the new numerator I'm going to get in both of these cases. And this one goes here. This one with the 2 will go here. And the one with the x will go second. So to get the denominators the same, I'm going to have to multiply this. What's going on? It's not letting me write over here. Okay. So I'm going to move this over a little bit. 2 divided by x plus 3 plus x divided by x minus 4. So I'm going to multiply this fraction, the first fraction, by what do I need to multiply? What do I multiply x plus 3 by so it becomes x plus 3 times x minus 4? I think that's quite obvious. I have to multiply the denominator by x minus 4. And if I multiply the denominator by x minus 4, I have to multiply the numerator by the same thing. And so this part over here becomes the 2 times x minus 4. And the x minus 4 is inside parentheses. And this one, to get this x minus 4 to look like x plus 3 times x minus 4, I have to multiply the denominator here by x plus 3. And I need to multiply the numerator by the same thing. So this new numerator is going to be x times x plus 3. And the two fractions I get will have the same denominators. So I just usually go ahead and write it as one fraction. The textbook does it slightly different, but we wind up in the same place. Now I use the distributive property to multiply in by the 2. I'm going to erase this now. And I get 2x plus 8 plus, and I'm multiplying in by a positive x. So that gives me x times x, which is x squared. And then x times the 3 gives me plus 3x. And then my denominator didn't change. X plus 3 times x plus x minus 4. Yeah, be careful because you get tired and you get bored and you go on writing this over and over again. So please do your due diligence and try and stay aware of what you're writing. What?
Is it 2x plus 8 or 2x minus 8?
Thank you. I wasn't paying close enough attention, so I made a mistake. Okay, thank you for catching that. I made a similar mistake in my 10 o'clock class and nobody caught it. So now I'm going to write the numerator. Well, I'm going to rewrite the denominator first because that's the tedious part. And the numerator, I'm going to look for my like terms. So I start with the highest exponent, x squared. There's only one x squared, so it's going to be x squared. And now I'm going to combine my x terms, my 2x and my 3x. So 2x and a positive 3x makes for 5x. So it's plus 5x. And then I only have one constant term, which is the minus 8. Now at this point, I need to look to see, can I factor my numerator? Well, the factors of 8 that subtract to 5. The factors of 8 are 1 and 8, 2 and 4. 8 minus 1 is 7, not 5, and 4 minus 2 is 2, not 5. So I can't factor this. It doesn't factor nicely. It doesn't factor to pretty integer numbers. So we're done. And then they ask for the domain. So I look at what happens in the denominator, because what happens in the denominator is what's going to determine our domain and range. And see, they wrote it as two separate fractions at this point, where I wrote it as just one fraction because they have the same denominator. And so this is the same thing I have here. And they get the same thing I did. And so we look at the domains of f and g, and the domains of f and g are what the domain of their sum is. X can't be -3 and x can't be 4, because either -3 or +4 makes 0 happen in the denominator. Any questions here? Okay. So subtracting means we're just going to subtract those two functions. So it's going to look an awful like what I did up there, which is the two divided by x plus 3 minus the x divided by x minus 4. Subtracting and adding fractions, the initial thing is to get the same denominators. So we're going to do the same thing we did up here when we were adding. So I'm going to multiply this fraction by x minus 4 divided by x minus 4, right? We're multiplying by 1. Multiplying by 1 doesn't change what it is, it just changes what it looks like. And same thing over here. We're going to multiply by the fraction x plus 3 divided by x plus 3. So we're going to do the same multiplies we did up here. But be very careful, because this is a subtraction here. Okay. With addition, we don't need to be too careful, but with subtraction, we do. So this is going to be 2 times x minus 4 minus x times x plus 3. Now, if this x, if it wasn't x, if it was an expression like x plus 2 or something like that, then I would put that inside parentheses as well. But it's not, so I'm not worried about that. So I have x plus 3 times x minus 4 in the denominator. So I'm going to multiply in by the 2, so that's going to happen the same way. So I get 2x minus 8. I did it correctly this time. But here, I'm not only am going to multiply in by the x, I'm going to multiply in by the minus sign. So I'm multiplying in by a minus x. Minus x times x is a minus x squared. Okay. Up here, I was multiplying in by a positive x, so I got a positive x squared. or plus x squared. Now I'm going to multiply minus x times plus 3, which gives me a minus 3x. And my denominator remained the same. X plus 3 times x minus 4. Again, I did not multiply my denominator out because I might be able to reduce the fraction. So now I go through, I do the same thing I did up here. I start with the x squared term and I write that one first, which is a negative x squared. I keep the sign with the number, with the term. And now I have a 2x minus 3x. Well, 2 minus 3 is a negative 1. So I have a negative 1x. And then the constant over here is the minus 8. So we have a minus 8. And so that gives us x plus 3 times x minus 4. Now right here, since my leading coefficient is negative on the x squared, I want to factor out the negative. So I'm factoring, it's like factoring out -1 of all 3 terms. So that's going to be a negative times x squared plus x plus 8. And I'm still dividing by the x plus 3 times the x minus 4. All right. Now this negative sign gets pulled out in front of the fraction because we like our fractions to be negative. If I have a negative numerator, then that means the fraction is negative, and I move the negative sign outside. So now I don't need the parentheses in the numerator. So now it's x squared plus x plus 8 divided by x plus 3 times the quantity x minus 4. Now I look to see, can I factor this numerator? Well, the factors of 8 that add to 1. Well, the factors of 8, which is 1 and 8, 2 and 4, neither pair of those add to 1. So we're done. This is the subtraction of the two functions. Okay. Now on the test, you will have these, but you won't have fractions to worry about. I don't test you over fractions, not directly. And so it'd be two polynomial functions that you'd be adding and subtracting and multiplying and dividing. And so this gives us, and then we look at the domain. The domain is x is not 3 and -3 and x is not 4. And so that's the condition that x has to meet to be in the set. X cannot be -3 and x cannot be +4. So that's my domain. And they go through the exact same process. Okay. Please realize after class today, I'm going to put this PowerPoint in files in Canvas. So in Canvas, there's one of the menu items when you pull up this course in Canvas is files, and this will be in there. I will probably create another folder inside files that will say PowerPoints. And because if I give you other PowerPoints, they'll all be in the same folder. Okay. Now. Oh, and so the domain, yeah, the domain is the same. The domain winds up being the exact same thing. Now, the next thing we're talking about, multiplying. So we're going to be multiplying two fractions together. What happens when you multiply two fractions together? Someone tell me. Tell me what happens here when you multiply these two things together.
You multiply across.
Right. Is the easiest freaking thing to do with fractions is multiply them. 2 times x, 2x. X plus 3 times x minus 4 is x plus 3 times x minus 4. We're done. That how difficult was that? Okay. So so now again we look at the domain of F, and the domain of G is what's going to be our domain in this case. So far all the domains have been the same. That doesn't always happen. Now, when we're dividing, this is where things get kind of screwy. And so that's also why I'm going to try and get to a blank page. So now we're going to be dividing the two functions. Boom. They do something that they don't explain what happens. X plus 3, 2 over x plus 3 being divided by x divided by x minus 4. So I'm dividing by the denominator. So this is the expression 2 over x plus 3 being divided by the fraction x divided by x minus 4. So I changed division to multiplication. So this is going to be 2 over x plus 3 times, and I changed the division to multiplication by multiplying by the reciprocal of this fraction. So that's going to be x minus 4 divided by x. And now we just multiply. So that's going to be 2 times the quantity x minus 4 being divided by the quantity by the product of x times x plus 3. When it's a single term times binomial or an expression, you usually put the single term first. So writing this as x plus 3 times x is perfectly correct, but we usually write it this way. I don't think MyLab counts off for writing it the other way. I definitely don't. But I will write it that way every time. Now, everything is factored. There's nothing that disappears. There's no factors in the numerator that are exactly the same as the denominator. So we're done. And all that's left is, see, they didn't show how they got from here to here. But we're dividing by the denominator, so that's the same as multiplying by its reciprocal. I usually explain why that comes out this way, why dividing by a fraction is the same as multiplying by its reciprocal. But I'm not going to do that. But if you want to know why, I'll hang on at the end of class. Okay. And so now we're going to look at, well, about the domain. Again, we have to talk about the domain of the numerator and the domain of the numerator and denominator. So the domain of F and the domain of G still are in play because this is the original function. So we want to consider the fact that in this case here, x can't be -3. X can't be -3. And in this case, x can't be +4. But now we have to consider what happens here. Well, here we also include that x, I forgot the x is not equal to 0. All right, because -3 and -4 are excluded because of the domain of f and the domain of g, but we also have to exclude 0 because of what happened when we combine the two functions by dividing. So not only do I need to look at the original function's domains, I also have to look at the domain of the resulting function. So we added another restriction. So -3 will make the denominator 0. 0 will make the denominator 0. And I can't use 4 simply because I'm dividing by the function g, which excludes the number 4. So this is my domain. I exclude another number from the real numbers for my domain. And so we are officially done with the first section. And y'all are free to go. Well, no, let me go in. No, we got a few more minutes here. Let me go ahead and start this. Identifying the graph of a function and obtaining information from or about the graph of a function. Well, this is the first part is easy peasy. So we have the vertical line test. If we have the graph of something, so we have a graph, is that graph the graph of a function? Well, if I draw a vertical line through it, if I draw a vertical line through A or a vertical line through B, does it hit the graph? Does it hit the graph at most at one point? So that's every vertical line. So if I look at this, am I going to have a vertical line that hits this graph in more than one place? If I draw a vertical line, will it hit this graph in more than one place? Well, if it doesn't, then it's a function. So every vertical line that hits graph A will hit it at exactly one point. Every vertical line that hits graph B will hit it at exactly one point. So both of these are functions. All right, here are two examples of two graphs that are not functions, because every vertical line hits the graph at one or more points. So in case of letter C, there's only one vertical line that will hit it at exactly one point. All the other vertical lines that hit it will hit it at 2 points. And this is a parabola that's a parabola in the y direction. I mean, it's a function of y, not a function of x. So functions of y are not considered functions for our purposes. And same thing is true of letter D, but letter D is the graph of a conic section called a hyperbola. And if we have time, we'll talk about conic sections. And there's only 2 vertical lines that will hit this graph at exactly 1 point. All other vertical lines that hit this graph will hit it at exactly 2 points. So the vertical line that goes through this point here and the vertical line that goes through this point here hit the graph at exactly 1 point, but I have more vertical lines that hit it at more than 1 point, so they're not functions. They're pretty graphs and neat graphs and things that have qualities about them. Well, if you notice, this X value went to 2 different Y values. This X value went to 2 different Y values. Same thing over here. This X value went to 2 different Y values, which negates the definition of function. So these are not functions. Okay. So here we have a, oh, time is it? We don't have time to go much into this. And so these are some questions they're going to want us to answer. Please notice there's a blank space here. And we'll start with this slide next time. This is this set of this PowerPoint is an updated version of the PowerPoint I used to work with, because we used to use the 10th edition of this textbook, and now we're using the 11th edition of this textbook. And because of that, they rewrote all the PowerPoints, except they weren't careful. And so there are some big mistakes that happen. They forgot to put in an equation here. And so I'll put it in. And I don't think they have an answer for E in this. So we'll deal with that when we come to it. So if you have questions, now's the time to ask, or you can send me emails, or when you're working the homeworks, you can send me emails from the homework. Oh, did I show that? Did I show in my lab how you can send me an email about a question in the homework? Because you have, I did it in one class today. Was it this class?
You were going
Actually,
over it, but show on the screen. We couldn't see it.
Okay, I'll pull up a problem and just very quickly show you that. I gotta pull up a problem first. Let's see, let's jump down here to number 19 and come over here. Okay, so they used to have a little it used to be over here where you had the help stuff, but now it's just across the bottom, so you don't have to pull down a menu. It used to be a menu that had a bunch of menu items. Well, and I usually like to, boom, it's a larger screen. And so you still see this, right?
Yes.
Okay. So you can help me solve this. I would suggest not using that. View an example is probably a better way of doing this. Because if you do help me solve this, you don't get credit for the problem. And view an example, they'll go step by step how to go through to solve it. And then you use those exact same procedures for this. And then get more help. Well, you can go to the textbook for this section. And then here's Ask My Instructor. You click this and boom. It will send me a link to this question, but you got to tell me what your issue is. I'm not understanding, or you answered this problem and it told you you are wrong, even though your answer and their answer looks exactly the same. Then this is where you tell me that, and then you hit send, and I get an email. See, it sends it to me. Okay. Yeah, I had one person one year who used this on about a third of the problems that he or she worked. I can't remember if it was a male or female, but and then view an example. Let me see what it does here. So, and then it shows you what to do. And so this is subtracting functions. R minus C of X is what we're trying to find. So revenue minus cost is profit. And so revenue minus cost gives us our profit. And so combining these, so that means I'm going to subtract this, so it's minus. I'm going to subtract this, so it's plus. I'm going to subtract this, it's minus. Subtracting this is minus. Combining like terms gives me this animal down here. Okay, because negative 1.7 plus 2 is a positive 0.03. The x cubed remains the same. The linear term, the x changed because I'm subtracting 35 from 265. And there's only one constant. These are fixed. This is a fixed cost. $850 is a fixed cost. So there's no variable with it. It's just, that's a cost per, is this in, it's usually over a time frame, but this could be a yearly time frame. So per year, there's $850, boom, or per month, it's $850 that goes out no matter what. And so, yeah. And so that gets subtracted from profit. This gets subtracted from profit, and this gets added to profit. So, and so this tells me how I'm doing this. And so I'm gonna subtract so this expression here, I'm going to subtract this expression here. So it's set up the exact same way. I'm going to subtract this, add this, subtract this, subtract this. So combining like terms, I get a new expression, which is the profit margin. Okay, and then then letter B, I put 13 in for X and find out what that number gives me. So that's a strictly calculator problem. So 13 squared, and then, well, I'm going to get negative 0.06 X to the third power. So I'm going to take 13 to the third power and multiply it by a negative 0.06. And then this is going to be a positive 0.8 plus 0.8 X squared. So I'm going to square 13, which is 169, and double it and add that to whatever number I get here. And then I'm going to subtract 35 times 13. And then I'm going to subtract 650. And so that's going to be the answer, letter P, and then interpret that profit. Okay. So 1,300 cell phones will give me a profit of so many hundreds of dollars. I think that because that's what it's in hundreds. Yeah. Oh no, it'll just give me strict dollars. Okay. Yeah, we're past time, so if you need to go, go. We're 7 minutes past. I'll stop the share. So I was just running through an example, so I didn't actually work it though. So y'all have any more questions for me or thoughts or concerns? Hopes, wishes, dreams. I can help with some, but not all.
When should I expect the video to be uploaded?
Expect what?
When should I expect the video of this lesson to be uploaded to YouTube?
Sometime today.
Okay.
It'll be later in the afternoon because it takes about an hour to get me the video.
Alright.
It used to be longer, but they've shortened the process.
Okay.
Any other questions?
Nope. Thank you.
All right, you take care. Bye.
You as well. Bye.